Hello, welcome to our video on routine extended detention basin maintenance, a guide for property managers, landscape contractors, and stormwater maintenance personnel. This instructional video was developed by the Colorado Stormwater Center at Colorado State University, with funding support provided by the Colorado Department of Public Health and Environment, the Urban Drainage Flood Control District, and the Colorado Stormwater Council. Extended detention basins, or EDBs for short, are one of the most common stormwater BMPs used in Colorado. EDBs operate by capturing stormwater in a basin and slowly releasing the stormwater over a period of 24 to 48 hours. They're designed to provide two important benefits: pollutant removal and downstream flood control. As runoff sits in the EDB, pollutants settle out to the bottom, leaving cleaner water to be discharged to downstream lakes, rivers, and streams. In addition, the slow release rate reduces downstream flooding. EDBs require various maintenance activities to remain operating properly. These maintenance activities can be generally classified as routine and non-routine. Routine maintenance activities are performed more frequently, at least once per year. Non-routine maintenance activities occur less frequently, are more expensive, and are generally the result of not performing routine maintenance activities properly. In this video, we focus on performing routine maintenance activities properly to avoid or delay non-routine maintenance activities later on. EDBs have multiple components that each serve a unique function. These components include the inlet, forebay, trickle channel, micropool, outlet structure, and embankments or side slopes. Each component must be inspected and maintained to assure the EDB remains operating properly. The inlet is where runoff enters the EDB. The inlet should be kept free of trash, sediment, debris, and vegetation at all times to allow runoff to enter the EDB. It is also important to look for signs of erosion or wearing away of soil near the inlet. Over time, erosion can lead to structural damage and excess sediment loading to the EDB, both of which are expensive problems to fix. The forebay is a concrete structure located immediately below the inlet and is designed to slow down incoming runoff and to collect large sediments and debris. Sediment and debris should be removed from the forebay regularly, typically several times per year. Cleaning out the forebay regularly will prevent sediment and debris from migrating further into the EDB, where it is more difficult and expensive to remove. For smaller EDBs such as those shown here, forebay sediment removal can be performed by hand using shovels, buckets, and wheelbarrows. Larger EDBs may be designed so that sediment can be removed mechanically using a skid steer, excavator, or other large equipment. The trickle channel or trickle pan is a small channel typically constructed of concrete or rock that conveys small flows directly through the EDB to prevent standing water problems within the EDB. Any noticeable sediment or debris should be removed from the trickle channel to prevent low flows from being diverted into the EDB and causing standing water problems.
So here we have a trickle channel that hasn't been maintained and is full of sediment and debris. It's blocking the sediment and debris are blocking the low flows, and the water is being diverted off to the sides and killing the vegetation. This trickle channel needs to be maintained very easily with a shovel and wheelbarrow or bucket.
If an EDB has not been properly maintained, the trickle channel may be fully or partially buried under sediment. This is an indication that major sediment removal is warranted for the entire EDB. It is also important to remove large woody vegetation that is growing near the trickle channel, as the roots can eventually damage the trickle channel, resulting in the need for expensive repairs. The micropool is a structure located immediately next to the outlet structure and is designed to hold 2 to 2.5 feet of water at all times. The primary purpose of the micropool is to reduce clogging of the outlet structure. However, it is also efficient at removing large amounts of sediment. Sediment should be removed from micropools once 6 to 12 inches have accumulated. Depending on the site, this may be required once every 1 to 5 years. Micropool sediment removal will typically require the use of a vacuum truck capable of removing large quantities of water and sediment at the same time. The outlet structure is the most important component of an EDB, as it controls the rate of discharge from the EDB, for both pollutant removal and flood control purposes. The outlet structure itself is composed of several subcomponents, such as the well screen, orifice plate, and trash rack. The orifice plate is designed to maximize pollutant removal from the EDB, and the well screen, located in front of the orifice plate, is designed to prevent the orifice plate from clogging. Debris trapped in the well screen should be removed several times per year, typically after large storm events. This ensures that the EDB continues to remove pollutants effectively and will prevent standing water problems. It is never acceptable to remove or otherwise modify the well screen or orifice plate to reduce standing water. If you notice the well screen or orifice plate is modified or removed, you should contact the local stormwater utility to assist with installation of a new one. Trash racks are appropriately named components designed to prevent large floatable debris from exiting the EDB and clogging downstream pipes and littering waterways. Trash racks tend to accumulate trash and other debris fairly quickly and should be cleaned after large storm events. Failure to keep trash racks free of debris can lead to standing water problems, or in a worst-case scenario, clogging of the outlet structure or downstream pipes, which could cause unnecessary flooding elsewhere. EDBs that don't have micropools will accumulate sediment, debris, and overgrown vegetation near the outlet structure. These materials should be removed at least once per year.
So the problem here is that the well screen or the trash rack for the orifice plate has not been maintained and is clogged with grass, clippings, and other trash. That has caused water to back up in front of the outlet structure, and we now have a standing water problem, as you can see, with all of the vegetation that is growing here and all the sediment that has accumulated. To fix this problem, someone needs to first of all come in and clean off the trash rack, and then come in and clean out all the sediment that's accumulated in front of the outlet structure, including the vegetation.
Embankments should be kept well vegetated with turf grass or other vegetation to prevent erosion and excess sediment from entering the EDB. It may be necessary to install permanent or temporary irrigation systems to establish and maintain healthy vegetation. In addition to keeping the individual components of EDBs operating properly, routine EDB maintenance also involves proper sediment disposal, proper vegetation and landscape management, and dealing with standing water issues. Removal of sediment, trash, and other debris is the most common maintenance activities for EDBs, and it is important that these materials be removed from the site and disposed of in a landfill. In some cases, it may be necessary to let wet sediment dry out for a day or two before the landfill will accept it. It is not acceptable to leave these materials on or near the site, nor is it acceptable to dispose of these materials at a yard waste facility. EDBs should be maintained in the same manner as any other landscaped area to ensure it maintains an aesthetic appearance. This includes providing supplemental irrigation if necessary, and the removal of invasive plants and weeds. However, the use of herbicides and fertilizers should be minimized, or preferably eliminated altogether, since these chemicals have a direct pathway to our waterways. Most urban runoff has high levels of fertilizers from upstream sources, so EDBs are bound to receive plenty of fertilizers by their design. EDBs are designed to fully drain within 1 or 2 days after a storm. Standing water that is present more than 48 hours after a storm, or dead vegetation within an EDB are both indications of a problem with the EDB. In many cases, this is simply due to the outlet structure being clogged with sediment or debris. However, if the outlet structure is not clogged, check to see what is preventing the water from reaching the outlet. It may be that sediment has accumulated in another part of the EDB and is blocking the flow path, or that the outlet structure was installed too high. Excessive standing water problems may require a redesign or modification of the EDB to correct drainage. The EDB owner should consult with a stormwater engineer to evaluate the situation and design a solution. In review, please remember that EDBs provide important benefits to society, such as pollutant removal and flood control, and that routine maintenance will not only assure the EDBs will operate properly, but is likely to save the owner money in the long term by preventing or reducing more expensive maintenance activities. Thank you for your time, and please visit the Colorado Stormwater Center website for additional stormwater BMP maintenance resources and training opportunities.